-3.
No.
No, I mean +3. -2. 2.
No. Notice you're subtracting a bigger number from a smaller number. They're both positive numbers. You're doing subtraction. Whenever you subtract a bigger number from a smaller number, the answer has to be negative.
-2.
If it was 9 minus 7, it would be +2. But if it's 7 minus 9, it's -2. Now, we don't necessarily need to change this to an addition problem, and I'll show you why. It doesn't help that much. In fact, it complicates it a little bit more. If I try changing this to an addition problem, and then making that a -9, now I've got 7 plus a -9, which is definitely -2, so it doesn't hurt doing it that way. You can still figure it out, but you don't need it. It makes it harder, not easier. If you just think of it as there are some subtraction problems that you don't have to turn into addition problems. This is one of them. Just treat it as a subtraction problem.
Okay.
Just make sure that you realize whether you're subtracting a bigger or a smaller number.
-1. 10.
Okay, give me a sign first on whenever we have multiplication or division.
+10.
Good.
60.
+60. So all I'm trying to do is make sure you pay attention to the most important thing first, which is the sign.
-1. I mean 4.
Okay.
+36.
Good. Very good.
-5.
No. Okay. Do you have a pencil and paper in front of you?
No.
Can you get one easily?
No.
Okay. In the future, if you'd have a pencil and paper in front of you, I think it would help a little bit. Because otherwise, it's just you're paying attention to everything I'm doing. Okay. Here is a subtraction problem. There's the subtraction sign right there. Correct?
Yeah.
And it involves not two positive numbers, but there's another negative sign in the problem.
Yeah.
These are the kind that you need to do in 2 steps. And the first step is to change the subtraction sign to a positive, and then change the sign of what was being subtracted, which was a +6. We're going to now, instead of subtracting a +6, we're going to add a -6. Well, what is -11 plus -6?
Positive,
Nope, not doing multiplication here.
-17.
Okay. So that's the rule. When you have a subtraction problem involving a negative number, you need to do it in 2 steps. You can't just guess. -5. You have to go through those 2 steps that I outlined.
Okay.
Same thing here. You got a subtraction problem, and it involves not 1 negative number, but 2 negative numbers.
Yeah.
So what do? 2 steps. Tell me what they each are. What's the first step going to be?
-4. -3, I mean. 2. Sorry.
Okay, what's the first step going to be?
You're gonna turn the subtraction sign into addition.
Okay, like this. And then what do I have to do because I did that?
Change -9 into +9.
Okay. Now the problem is I've got two positives together, so I know that's just the same as one positive. So it's like that. Okay. And then what's the answer to that?
-2.
Not -2.
+2.
Yeah. Notice that when I'm doing addition, A plus B is the same as B plus A. Okay? But when I have a -7 plus a 9, I can switch them because I'm doing addition. So it's the same as that. Now
Yeah.
what's 9 minus 7?
-2.
Which is it?
+2.
Okay. Tell you what, I want you to give me the sign on everything first, not just multiplication and division. Sign
Positive.
on everything. So +2 here. Okay. You don't have to type the sign in when it's positive, but I want to hear it first.
+3.
Good.
Negative.
Oh, this is a two-step problem. You got to do it in 2 steps.
+6.
Good.
+12.
Good.
-8. -10.
Good.
-66.
Good.
-44.
All right. That's a lot better. Have you been working on it?
A little bit.
Okay. Let's do a little algebra so that you see why those other things are so important. I'm going to give you some equations to solve. Please solve.
I don't. Give me a minute. I gotta get a pencil.
Jackson,
I can't tell who you're talking to, Jackson. You talking to me?
Here's that. Just use that for now, and I'll get one.
Can we do some stuff like the stuff that we did last time?
Did you send me anything new?
No, it's the pink paper.
We can definitely do that stuff, but no, that's fine. Let me take a look at some of the stuff. Well, let's see. Look at the first one. Okay, we've done some of these. That's upside down. I can't rotate it. But I think I have it right side up also. That's the second page. We can work on this, I think. Let's see how many times I can blow that up without it rotating. Ah, good. Okay. Notice that when you take the picture at an angle, everything at the top is blurry.
Yeah.
So you got to hold the camera directly above the photo in the center and take the picture. And then you can read all of it. Like I can't read that first problem right now. Problem number 8, I guess it would probably be. So whoever's taking the pictures needs to do that. I don't know if it's you or your mom or whatever. But let's see. We can do number 10. It's not that I don't want to help you with these problems. I do. It's just that working on these are so much less important than getting a good, strong foundation. You want to go into high school with a good, strong foundation. And by that, I mean good at arithmetic and good at solving equations. This is a little more advanced stuff. And I'm happy to go through these with you. It's just that I don't think you're learning as much when we spend a lot of time on these. And part of that is because you still need to get better at your foundation stuff. But let's go ahead and look at these. A hot air balloon starts on the ground and is ascending. What does that mean?
Going down.
Going up. It's a hot air balloon. Descending is down. Ascending is up. And it's going at 3 feet per minute. Okay? Now, what's the slope of that balloon?
Well, wait.
In other words, that's why I don't think these are as helpful. These are physics problems that are turned into algebra problems, and they're trying to teach you about linear equations. It's just, I'm not that impressed. There's easier ways to teach it. But nonetheless, okay. So what they keep giving in all of these problems is a slope. When they give you a rate like 3 foot per minute, that's the rate of change. That's the slope. What's the general formula for an equation of a straight line?
Y equals mx plus b.
Yeah. So y equals mx plus b. What's m stand for?
M stands for slope.
What's b stand for?
The y-intercept.
Okay. So in this case, we know that y equals, it's going up at 3 feet per second. Well, a hot air balloon started on the ground. Now, your horizontal scale here, that's another thing. This is time. It's not x, it's t. And this is h, height. Okay? Here, let me move some of this so it's not confusing. When I'm labeling that horizontal scale, I got to know what it is. And what we're dealing with here is time. Okay? Well,
Yeah.
at 0 seconds, which is when the balloon starts, what's its height?
0 feet.
Right there. Okay? So what's its y-intercept?
The y-intercept would be 0.
Correct. What's its slope?
0.
No, its slope is the rate that it's going up.
Oh, the rate that's going out. Wait, I can't see it.
3 feet per minute.
Oh, I see now. Yeah. 3 feet.
Okay. So if I draw a straight line, that's how that balloon is going up as time passes.
Yeah.
In other words, after 1 minute, it's 3 feet off the ground. After 2 minutes, it's 6 feet off the ground. You get that?
Yeah.
Okay. Now, So that is the equation for the first balloon, because its y-intercept is 0. And now there's a second hot air balloon. But it doesn't start on the ground. It starts at 45 feet. So what is its y-intercept?
45.
Okay, right there. And what is its rate?
Oh, can't see.
It's right here.
Oh, yeah. 3 feet.
No.
Oh, wait, no, 2 feet. Sorry, I just couldn't see it.
2 feet, and is it going up or is it going down?
Down.
Correct, because it's descending. So what is its slope?
It's starting at 45 and it's going down every minute is 2 feet down.
What is its slope?
Oh, what, 2 foot?
Almost. Is it
No, 2 feet.
positive? Is it positive or negative?
2 feet.
It's negative. Because it's going down, it's descending at a negative slope, starts right there, and a 2-foot down slope is like that. Okay, so there's the second balloon. And there's the first balloon. You got it? The first balloon starts on the ground, going up at 3 feet a second. Second balloon starts right there, and it's going down at 2 feet a second. And notice the slopes we're looking at. That first one is a positive slope. Second one is a negative slope. They always have to match. And if you look at this equation over here, that's the equation of the second balloon.
Yeah.
Notice its slope is -2, not 2. Its slope is -2 times x, or in this case, t.
Yeah, I see it.
You can use either variable. It's just that when you're dealing with time, it's better to use t.
Okay.
Okay? There's so many things where you can call it x. You can call anything x. It's just that it makes so much more sense. If you imagine the picture, here we have this balloon like that. As time passes, which means we go to the right on the horizontal axis, the t-axis, we go up. And the second balloon is as time passes, we drop. So they're going to ask us, where do we meet? Okay, first of all, it says graph the two equations. We've done that. Interpret. They didn't ask us where we meet. What does that interpret the point of intersection? What is that point right there?
Where the 2 balloons meet.
Where they're the exact same altitude. They may not hit each other, but they're at the same. I guess if one were directly above the other, they would hit each other. But if one were offset just a little bit in a third dimension, they wouldn't have to hit one another, but they would pass the same altitude. So that means they're each same height or altitude. And you're talking about hot air balloons. Okay. A gym fit charges $10 each month plus a $50 enrollment fee. The gym is having a one-time offer. We did this one, I believe. We can do it again. Yeah, this is worth doing again. If we did do it once. I don't remember doing below the hot air balloon, but maybe there's some that are similar. So let's talk about this right here. We want to write an equation for the total charge. Total charge, I'm going to call it TC, is equal to what? And
PC
be thinking y equal mx plus b.
Oh, so it's
Only
equal
instead
to.
of y, it's tc.
I'm confused. I don't know why.
Okay. Well, let's start off by trying to define a variable. Okay. What should x represent? That's always the first way, really, to start out word problems.
X should represent the gym, like where the both gyms meet.
No,
Or the both.
right there. X represents how many months you're going to use it. In other words, the number of months. Once I have defined that variable, now you can write an equation. What is the total charge going to be? Ignore everything after the first sentence. Let's just get this first sentence into an equation. They're going to charge you $10 for each month you use it.
So
$50
y
fee.
equals 10 plus 50.
10x
10x, yeah.
plus 50. In other words, if you use it not at all, you're still going to pay $50. If you use it 1 month, you're going to pay $60. If you use it 2 months, you're going to pay $70. Okay? So in this case, in the previous problem, slope was the speed of the balloons. In this case, slope, the 10, is the charge per month. So in all of these problems, when they talk about a rate, either when they use the word rate or you see the word per minute means rate. Each month means per month. It's $10 per month. That's a rate. That's the slope.
Yeah.
And it's a bit of a calculus problem if you want the honest truth. That's why I don't really approve of this as the best method to teach you math. Serious. I'm dead serious. I could teach you math so much better if I didn't have to use any of this other stuff. It's causing us to waste time. And I'm not sure you're learning a little bit, but I just don't think it's the best way to go. But anyway, let's finish the problem. Okay? So, we got the equation for that first. Now let's look at their alternative offer. They are having a one-time offer where you get rid of the enrollment fee, but you have a charge of $15 per month. So, if I call that one y sub 1 for one-time offer, what's that cost going to be?
The one-time offer is going to be 15.
Don't forget the variable. You always need the variable. Remember, it's y equal mx plus b. What was x equal to?
15.
No, x is the number of months that you're going to use it. That's why this step here is vitally important in solving word problems. You absolutely have to know what your variable means. And in this case, the variable is the number of months you're going to use it. So what's the equation if it's $15 per month?
Y equals 15, 0.
15x.
Oh, yeah, because you haven't used it.
Well, it's got to be in this format. We need a y equal mx plus b. Now, in this second equation, b is 0. They have dropped the enrollment fee. Notice that in the first equation, the enrollment fee is b. That's where you start. No matter how many months you use, you start at the enrollment fee. Well, in the second case, they've dropped the enrollment fee down to 0, which makes B 0, but you still need an M, and you still need the variable X, knowing that X is the number of months. Okay. All right, so we've got our two equations. Suppose you do not take the special offer, write an equation that fits for the regular. It's that one right there. Okay?
Mm-hmm.
Write a second equation that represents the amount you would spend if you take the one-time offer. That's that one right there.
Yeah. Mm-hmm.
Now, graph the two equations. Okay, we'll do that. Over here on the left. I'll do it in two different colors. We'll start it at 50. And that slope is 10. So that's a pretty steep slope. So that's their standard. And then in blue, we'll graph this one right here, which is their one-time offer. We know that's 15x. Where does that cross the y-axis?
15x crosses the y-axis at the... Oh my gosh. Why is this so confusing?
Well, because this is not the stuff you should be working on. That's why. You're not... we only have a few minutes more. Let's just go ahead and work on this. In this blue equation, what is B? That's the y-intercept, right?
Yeah.
What is it in the blue equation?
1.
No. If it was 1, it would be a plus 1.
Oh, 15.
No, that's the slope. 0. Just like it was 0 in the hot air balloon that was on the ground. Well, in this case, it's a different type problem, but it's still a linear equation. It's very similar. Since they've dropped the enrollment fee, the starting spot is 0. So over here on the graph, it's that. But what is its slope?
The slope is 15.
Okay, that's a steeper slope than 10, which is the red line. So I want that slope to do something like that. Okay, that's steeper.
Mm-hmm.
15 is steeper than 10. So there is our graph of the two equations. We've done that. We've done that. We've done that.
Yeah.
Graph the two equations. After how many days would the one-time offer be a better deal? In other words, this is your cost right there, right? No matter what.
Yeah.
If you're only going to use the thing for 1 month, their one-time offer is the better deal. But
Okay.
Where do these intersect? Where those intersect is where they are equal.
Okay.
Okay, where y1 is equal to y. So if I'm going to solve this, I'm going to set 15x equals 10x plus 50. See over here on the right?
Yeah.
Okay. This is what we should be working on, is solving equations, because you don't know how to do this, and this is far more important than understanding these concepts. Do you know how to solve that equation?
Wait, which one?
One in blue. 15x equals 10x plus 50. Listen, I apologize, Jackson. I have a 7 o'clock tonight, and I'm just looking at my clock and realizing that I'm running over. So I would solve that. It's 5x equals 50, x equals 10. After 10 months, both costs would be the same. blue would start getting more expensive after 10 months. If you were going to use the thing for 11 months, you'd be better off with plan number 1. If you use the thing for 9 months, you're better off with plan their special offer.
Okay.
Okay? All right. I'll talk to you next time. You've got a session scheduled later this week. Talk to you. Bye-bye.